Ever pondered if you could alter your destiny just by changing the spelling of your name? Or have you ever been tempted to believe that the position of the stars at your birth can predict your future? These thought-provoking questions open the Pandora's box of pseudoscience, a realm filled with ideas that sound scientific but lack empirical evidence or logical reasoning. In our day-to-day lives, we encounter numerous such concepts, often cloaked in the garb of scientific jargon, and we may even be tempted to believe them. But do they hold water when scrutinized under the lens of rigorous science? From astrology to numerology, from homeopathy to the belief in ancient aliens, pseudoscience is woven into the fabric of our society. It's often hard to distinguish between what's scientifically valid and what's not. Intriguing, isn't it? Let's explore the 10 most common pseudoscientific ideas that need a reality check. Scene script. Have you ever read your horoscope and felt it was accurate? You might want to think again. Let's delve into the cosmic game of fortune-telling, also known as astrology. It's a practice that has been around for thousands of years, captivating minds with its alluring promise of revealing the future. It's a seductive idea, right? The notion that the stars and planets aligning at your time of birth can somehow predict your character and destiny. Astrology has an enduring popularity, with countless people across the globe consulting their horoscopes daily or even making life decisions based on their star signs. Yet, despite its widespread acceptance, it's essential to remember that popularity doesn't equate to scientific validity. Now, have you ever wondered why so many people find their horoscopes to be spot on? Enter the Barnum effect. Named after P.T. Barnum, the showman who famously said, "We have something for everyone." The Barnum effect refers to the tendency of individuals to believe that general statements about personality apply specifically to them. Astrology plays this game well, providing vague and broad descriptions that anyone could relate to, making it seem like a personalized reading. But here's the kicker. While astrology is an ancient practice, it's not a science. Science is about evidence, testability, and repeatability, about forming hypotheses and then trying to disprove them. Astrology, unfortunately, falls short in these areas, with a lack of empirical evidence supporting its claims. Numerous studies have shown no correlation between astrological signs and personality traits or future events. Moreover, astrology doesn't account for the changes in the sky over centuries due to the precession of the equinoxes. The signs of the zodiac, as we know them today, are off by about 1 month from where they were over 2,000 years ago. So if you think you're a Sagittarius, you might technically be a Capricorn. In essence, astrology lacks the scientific backing to predict personal or global events. While it might be fun and harmless entertainment for some, it's important to remember that it's not a reliable guide for understanding ourselves or the world around us. Numbers running your life might sound like a plot from the Matrix, but it's a real belief. This belief is known as numerology, a pseudoscientific practice that dates back to ancient times. Originating from the Pythagorean idea that the world is built upon numbers, numerology suggests that numbers can influence our lives in significant ways. The allure of numerology is understandable. We humans are pattern-seeking creatures, always looking for meaning in the world around us. But while numbers play a crucial role in our lives, from keeping track of time to making calculations, their influence is not mystical or predictive. Scientifically speaking, there's no evidence to support the claim that the numbers associated with your name or birth date can predict your future or define your personality traits. It's important to remember that correlation does not imply causation. While numbers indeed rule the universe, they don't necessarily dictate our personal lives. A cure that's just water? Welcome to the world of homeopathy. Now let's delve into the fascinating realm of homeopathy. Born in the late 18th century, homeopathy is a system of alternative medicine that was conceived by Samuel Hahnemann. It is based on the principle of like cures like, suggesting that a substance that causes symptoms in a healthy person can be used to treat similar symptoms in a sick person. Homeopathy also embraces the notion of minimal doses. It suggests that the lower the dose of the medication, the greater its effectiveness. This is achieved through a process called potentization, where the substance is diluted in water or alcohol and then shaken vigorously. But here's the catch. The substance is often diluted to such an extent that not a single molecule of the original substance remains in the solution. It's like finding a single grain of sugar in an ocean. So it's essentially water or alcohol. And this is where the scientific community raises its eyebrows. Now, does homeopathy work? Some people swear by it while others dismiss it as quackery. Scientifically speaking, the jury is still out. Most studies attribute any benefits of homeopathy to the placebo effect, where a patient feels better not because the treatment is effective, but because they believe it is. This is not to belittle the power of belief. The placebo effect is a real phenomenon, and it can influence how we perceive our health. However, for a treatment to be accepted scientifically, it needs to work better than a placebo when tested in rigorous, double-blind, placebo-controlled trials. Unfortunately, homeopathy hasn't consistently met this standard. Despite numerous studies, there's still no substantial evidence to show that homeopathic remedies work beyond the placebo effect. This doesn't mean that all homeopathic practitioners are charlatans or that all patients are deluded, but it does highlight the need for more robust, unbiased and transparent research in this field. Until then, it's best to approach homeopathy with a healthy dose of skepticism. In short, homeopathy's effectiveness beyond placebo is yet to be scientifically proven. Can pyramids sharpen razors or preserve food? Let's find out. Pyramids, the colossal structures that pepper the landscapes of Egypt and other ancient societies, have been the subject of numerous pseudoscientific claims. Some have proposed that these geometric wonders possess a mysterious pyramid power, allegedly capable of everything from sharpening razors to preserving food. However, these claims, as fascinating as they may sound, lack the backing of empirical evidence. Extensive scientific research has failed to confirm these extraordinary assertions. For instance, the idea that a razor, when placed under a pyramid, can somehow regain its sharpness has been tested and debunked. Similarly, the notion that pyramids can preserve food, like an ancient refrigerator, has also been discredited. Truth be told, these structures are extraordinary, not because of some mystical energy they supposedly possess, but because of their architectural brilliance. The pyramids stand as a testament to the ingenuity and engineering prowess of ancient civilizations. Pyramids, as it turns out, are more of an architectural marvel than a mystical energy source. Crystals are beautiful, but can they heal? This question has been at the heart of numerous debates, with proponents of crystal healing asserting the positive energy they claim to receive from these shiny pebbles. But what does science have to say about it? Crystal healing is a pseudoscientific practice that involves the application of crystals or gemstones to the body, with the belief that they will draw out negative energy. The advocates of this practice argue that each crystal has a unique vibration frequency, and when placed on the body, can interact with the body's energy fields or chakras to promote physical and emotional healing. However, there's a crucial element that we need to consider here: the placebo effect. This is a psychological phenomenon where a person experiences a perceived improvement in their condition due to their belief in the treatment, rather than the treatment itself. The power of belief can be strong, and when someone truly believes that a crystal can aid in their healing, they may feel better, but this doesn't mean the crystal itself has any healing properties. The scientific community remains skeptical about crystal healing, largely due to the lack of empirical evidence. Despite numerous studies, there's no scientific proof that crystals and gemstones can cure illnesses or alleviate symptoms. The mechanisms by which crystals would be able to influence our health are also unclear and not supported by scientific principles. Moreover, it's important to note that relying on crystal healing can have serious consequences if it replaces conventional medical treatment. For conditions that require medical intervention, turning to crystals instead of seeking appropriate medical care can lead to adverse outcomes. So, where does this leave us? While crystals may indeed be captivating with their variety of colors and shapes, and may even have a place in our homes as decorative items, they do not have any scientifically proven healing abilities. They are, in essence, just shiny pebbles. Therefore, crystals, while aesthetically pleasing, don't possess scientifically proven healing properties. They are beautiful to behold, but let's not attribute to them powers that they simply do not possess. Let's take a trip around the world, or is it across? Pause for a moment and ponder. This brings us to our next pseudoscientific concept, the flat Earth theory. A notion that has persisted for centuries, despite the overwhelming scientific consensus that our planet is, in fact, an oblate spheroid. The flat Earth theory proposes that our world is a flat, disc-shaped plane with the Arctic Circle in the center and a giant wall of ice, what we know as Antarctica, encircling the outer edges. This theory, while fascinating in its audacity, is woefully inaccurate and contradicts the vast body of scientific knowledge we've accumulated over millennia. But why is this theory, so clearly refuted by empirical evidence, still prevalent in some quarters? The answer lies in a deep-seated mistrust of the scientific establishment and a preference for personal observation over scientific data. This perspective, while appealing in its simplicity, is fundamentally flawed. It dismisses the rigorous process of scientific inquiry and the weight of accumulated knowledge, which is built on the collective work of countless scientists over generations. So, what's the evidence against a flat Earth? Well, there's plenty. For starters, we have photographic evidence from space missions showing our beautiful blue planet as a round object floating in the vast expanse of space. Then there's the phenomenon of lunar eclipses, where the Earth's round shadow is cast on the moon. And let's not forget the way ships disappear over the horizon, hull first, then mast, a clear indication of the Earth's curvature. The danger of rejecting scientific consensus is significant. It undermines the value of scientific inquiry, encourages misinformation, and can lead to harmful decisions. Science is not a matter of belief, but a process of discovery and understanding. The Earth, as overwhelming evidence suggests, is not flat. It's a beautifully complex sphere spinning in the vastness of space, and we are fortunate to call it home. Quantum physics is complex, but does it really hold the key to understanding consciousness? The microcosm, the world of the infinitesimally small. It's here that quantum physics reigns supreme, governing the behavior of particles at scales so tiny they defy our everyday logic. The realm of the quantum is where particles can exist in multiple places at once, where they can be both a wave and a particle, where they can be entangled over vast distances. It's a realm that's truly stranger than fiction, but here's where things get a bit complicated. When this fascinating branch of physics is misused in pseudoscientific claims, we run the risk of misunderstanding the microcosm. You see, some have claimed that quantum physics can explain consciousness, that it can provide a scientific basis for paranormal phenomena, or that it can even unlock spiritual truths. The idea is tantalizing, isn't it? Quantum physics, after all, is deeply mysterious, and so is consciousness. So it seems like a match made in heaven, right? Well, not exactly. The problem here is that these claims often lack supporting evidence. To date, there's no scientific consensus that quantum physics can explain consciousness or any other paranormal phenomena. These are complex, multifaceted issues that cannot be neatly explained away by invoking quantum physics. Moreover, it's important to remember that quantum physics, like any scientific field, is not a magical key that unlocks all of life's mysteries. It's a tool, a lens through which we can better understand the universe at its most fundamental levels. But it's not a catch-all solution for every scientific or philosophical question we might have. So, while it's absolutely worth delving into the mysteries of the quantum world, let's do so with a healthy dose of skepticism. Let's not jump to conclusions without solid evidence. Let's not misuse this wonderful branch of science in an attempt to validate unfounded claims. Quantum physics, while fascinating, doesn't provide a backdoor to paranormal claims. The microcosm is indeed a place of wonder, but let's strive to understand it for what it truly is rather than what we might want it to be. So, we've journeyed through a landscape of intriguing but scientifically unsupported ideas. From the cosmic game of fortune-telling, we've learned that while the stars and planets may impact our physical world, attributing personal destiny to their positions isn't supported by scientific evidence. Moving on to deciphering life's code, we've seen how some are quick to claim they can predict future health and personality traits from DNA alone. Yet, the reality is far more complex, as our genetic code is just part of the story. In the realm of health and wellness, we explored the supposed miracle cures that lack empirical support. While they may offer hope, it's essential to recognize the danger of replacing proven treatments with untested alternatives. We've marveled at ancient structures, often claimed to be sources of mysterious energy. But let's remember, extraordinary claims require extraordinary evidence. Next, we delved into the world of shiny pebbles, or as some would have us believe, powerful healers. While crystals are undoubtedly beautiful, attributing healing properties to them is not grounded in scientific fact. Our exploration took us across the globe, dispelling the myth that different locations have varying gravity. The truth is, gravity is a constant force, regardless of where you are on Earth. In the microcosm, we've debunked the misconception that water has memory. This idea, while fascinating, has no basis in our current understanding of physics and chemistry. In each of these cases, we see the allure of pseudoscience. It offers simple explanations to complex phenomena, providing comfort in a world that often seems unpredictable. But as we peel back the layers of these ideas, we find they lack the rigorous testing and empirical evidence that form the bedrock of true science. And so, we unmask the illusion. We remember the importance of critical thinking, of asking questions, of seeking evidence, because that's what science is all about. Remember, a healthy dose of skepticism can keep us grounded in the realm of science, free from the illusions of pseudoscience. Stay curious, stay rational, and keep exploring.